Hello and welcome to TD Design and Build. In this video I'm going to show you how to use Fusion 360 to design and build a spoilboard for a Onefinity CNC machine. So you've purchased the Onefinity CNC machine, you've waited the 3 months and the machine has finally arrived. Once you've set it up, one of the first things you're going to want to do is make a spoilboard. If you're thinking of using Fusion 360 for your design work, then this is the video for you. So let's head up to the office, fire up Fusion 360 and get this tutorial going. Here we are in the home screen of Fusion 360. You'll notice in the top left here it says Design. That means we're in the Design pane. If you click on this, it gives a list of other options for screens. The only two that we'll be using throughout this tutorial is Manufacture and Design. If you look over here, this little box allows the screen to be moved around. When we do sketches for CNC machines, we tend to do them in the top plane. The reason for this is because CNC machines operate two-dimensionally the majority of the time, especially with something like a spoilboard, which is what we're making. So we're going to click on Create Sketch at the top left here, and then click on the plane that we are using. If I just click here where it says Origin, all the planes drop down, and that tells you we are in the XY plane. As you know, the machine functions primarily in the XY frame, with the spindle moving up and down on the Z axis. So we're in the correct plane there. And the first thing we're going to draw is we're going to lay out the spoilboard. So what I've done is I've clicked on rectangle. This option allows me to draw squares and rectangles, but if I click down here, you'll notice I've got other options for different types of rectangles. What I want is center rectangle, and click on the center of the screen there, and as I draw the mouse out, it starts to draw a square which is centered around the center of the screen. For me, this is important because when you make a spoilboard, you are working from the center instead of from the bottom left as your origin point. When the spoilboard's down, most of your jobs will probably be orientated from the bottom left, but for a first job, you're starting in the center. And what I'm going to do now is type in my dimensions. So I type in 800, press tab, takes me to the next one, type in 800 and hit enter. I'll scroll out or zoom out there. You can see I've got this sketch of the board. What I now want to do is finish sketch and go over to extrude. Now we're going to turn that sketch into a three-dimensional part. And type in 18mm there, but you'll notice here to the right is a dialog box with a series of options in for your extrusion. You don't need to worry about any of these right now, but at some point in the future you might need to know what these options are. Click OK, and there you have a 3D representation of an 800 by 800 by 18 piece of MDF. The next thing we want to do is position our first hole on the board. So click sketch again, and then I click on the top of the board in the top plane. I'm going to click on rectangle again, and I'm going to find the bottom left of the box and 25 by 25. So it's automatically snapped to that. I'm going to click on point and put a point there. The reason I'm doing that is because I want my first hole to start 25mm from one edge and 25mm up from the other edge. Finish sketch, and that is my start point for the holes. So to create a hole, you're going to go up to the top left again and click on the hole feature. This is a great tool. What it does is it creates holes for you instead of you having to draw circles on the workpiece and then cut those circles out. You just click on this, dialog box comes up with a series of different options for different types of holes. You've got tapered, tapped, through holes, clearance holes, you name it. this tool will do it. So you click on the point that you've created and straight away it starts to create a hole for you. So it's a through hole, 18 millimeters deep, 11 millimeters for the counterbore, 0.8 for the depth of the counterbore, and 7 millimeters wide for the main hole. So just to discuss why I've picked those parameters, and by the way, you can change any one of these parameters. So if I just click on here and type in 30, you'll notice that gets deeper. But if I type on the diameter here for the counterbore, type 40, you see I get a much bigger counterbore, but it's 11 millimeters. So just going to explain why we pick those sizes. Coming up on the screen now, these are two types of threaded inserts. On the left is a permanent thread insert, on the right is a broken thread insert. I'm using this one on the right, so I know it needs a 7 millimeter wide hole that's full depth, and it's going to need a counterbore for this. And what this does is it stops the threaded insert from driving itself all the way through. The one on the left I've used as well, but it needs a slightly larger hole. I'm not using those for this example, I'm just using this one. The important detail to take note of is when your inserts arrive, you should measure them and make sure that you are making the correct holes for them. And all you do, again, is use the hole tool to match the requirements of the threaded inserts. So we've got the hole, we're ready to lay those holes out in a repeat pattern. How do we do that? Well, we click on this rectangular pattern feature here and it brings up this dialog box. You're going to want to select features and select objects. When you select objects, you can go down to the feature tree and click on hole here, or you can click on the actual hole here. And you click on directions. When you click direction, you'll notice that it brings up this coordinate system, and you can click on one of the lines and it will add 2 arrows letting you know that it's going to create a grid from your holes. The next thing to select is make sure it's on spacing. You don't want it on extent, you want it on spacing. Quantity, well, on an 800 by 800 board, if the holes are 50 millimeters apart, it's going to create 16. And the distance between each one is 50 millimeters. As soon as I type that, you can see that it's spaced out 16 holes 50 millimeters apart in the Y direction. What we want to do now is move all of those across into the X direction. We type 16 and 50 again, and it will create a grid. Just like that, that is the Spoilboard drawn. It'll take about a minute for it to process all of these holes and recreate that. And there you have it. So it's quite simple and easy with this bit of software. That took a couple of minutes and that's no problem. So what we have to do now is create the tool paths to create these holes. So we're going to click on design, go down to manufacture, click on that, and here we are in the CAM aspect of the software. If you look up at the top here, just briefly, you'll see all the different methods of cutting, and each one has a drop-down box with lots of different types of G-code for cutting different types of profiles. The same here, in 3D, you've got parallel, scallop, contour, but we don't need any of that for this particular tutorial. The first thing you do is click on Setup, and you're going to go to New Setup. Dialog box will appear. In that dialog box, the first option is to select which machine you want. Click there, and you'll see Autodesk generic 3-axis machine with the Onefinity CPS. This is the post processor for the Onefinity. So you click on that and it will change all your settings for the Onefinity machine. The next thing to look at is the origin, or the stock box point. Now, if you want to change your origin point on any model, all you do is at this stage, you click on any one of these points and it will move the origin to another position. And you can move it to the bottom or to the top, but you really need it in the middle when you're making a spoilboard, because you don't have that bottom left hand corner that you would usually use to probe off of. So what you're going to do is home the machine, and then you're going to send it to the middle of the work area, and you're going to start your program from the middle. So by leaving this coordinate there, when you send the spindle to the middle, you will home it to the middle and then start your program from there. So that's that. Now we're going to go to stock. So if I just orientate the model to the front here, zoom in, what you'll notice is when I click on add stock, you'll see that the workpiece essentially gets bigger. Now you can also see here stock dimensions 814 by 25. Now when you use an MDF sheet, it's only 18mm thick, so we can change this to 0 and we get 18mm. And here we're not really doing anything to the sides. Well, we are, but we don't need to worry about that for this. So we're just going to change that to 0, and we've got our base stock size 800 by 800 by 18. And that's the parameters of the workpiece put in. Now we can generate a toolpath. So the first toolpath we're going to create is going to be bore to drill all of the holes in the board. So we click on bore, on to tool. So when this dialog box comes up, you've got 5 windows. Now there's a lot of options here, and you don't really need to worry about any of them for this. So what I'm going to do is select the tool. This box comes up. If you want to add a tool, you click add. This window pops up and you can pick any number of tools and type in your parameters. We're not doing that. We're going to my stuff, where I've previously added all of the tools that I've used so far on my projects, and I'm just going to click on 6mm diameter end mill, and it changes all the parameters, including the feed rate for that particular tool. Next thing I'm going to do is click on the geometry tab, which will bring me to this dialog box, and I click on one of the holes, and as you can see, it's created a toolpath for that hole. If I click on the counterbore, it adds an additional toolpath for that counterbore. Now I don't need to go clicking on each individual hole. All I have to do is select same diameter, click, and it will generate a toolpath for every single one of those holes. Brilliant. Heights, I don't need to worry about changing any of the heights. Don't need to worry about passes. It's pretty much got everything in hand. So I can click OK. It takes a few seconds to generate the toolpath, and if I want to check the toolpath, I can click on simulate. This little video bar will appear at the bottom. Move this dialog box to the side, press play, and you can watch the toolpath working away. Now if I want to slow the video down, I just move this dot, and you can see it's really slowed that down. So if I need to, I can examine the toolpath, look quite closely, speed that up a bit, and watch what it's doing. Everything looks okay to me. Now, one thing I will say is a 6mm cutter boring out a 7mm hole is a bit close. You might generate quite a bit of heat doing that. I did it for my Spoilboard and had no problems with it, but just be aware that that is quite close, and usually you would use a smaller cutter to drill out or bore out the holes. So that's our first toolpath created. What we're going to do now is cut the perimeter. So we're going to use 2D contour, and the tool is the same. It kind of automatically knows that we're still using the same tool. So I'm going to click on the perimeter of the workpiece and go to passes. Now this is where I click on multiple depths. And the reason I do this is because I want to tell the tool not to just cut around the outside, but to take incremental steps down. Each one of those steps is going to be 3mm. I'm quite confident that the tool that I'll be using can cut 3mm in depth at a time, and there's no other options that we need to mess about with there. And it's that simple. It's generated the toolpath. What we'll do is go to simulate again, press play and slow it down a little bit to have a look at what's going on. I'll speed it up a bit. And that gives you an idea. It's going to work its way around the board, cutting 3mm lower each time until it's given us square sides. And the reason we do this is to make sure that the board itself is squared off to and parallel to the hole. So there's our two toolpaths. So what we want to do now is generate a G-code. So if you click on one of these and then click on post-process, what that will do is generate the code, and then you can save that on your computer somewhere. But we're not going to just do the one G-code at a time. We're going to press Control and highlight both codes. And what this does is it saves them as one. And when I generate the code for that, there'll be no breaks between the cuts. So it will cut all of the holes, and then it will cut the perimeter all as one program. So change the name to Spoilboard 101. Click on Post, and I'll go to Onefinity, G-code. And this is where I basically save all my Spoilboard G-codes and all of my G-codes for work. So save that, and that's that. Basically, it brings up this. All you need to do now is put it on your USB stick, go down to the machine. Okay, so some of you already know this, some of you might not. If you're waiting for the machine to come and it's your first CNC machine, then you won't know this. But whenever you program the machine to do a job, you're quite often starting from the bottom left corner. That's what this corner bracket's for, and this outlet allows you to put the probe in here, and you probe to this corner, which tells the program where to start the job from. You can also probe from other points of the board if you've got a corner bit, let's say if you're working here. But when you make the Spoilboard for the first time, you don't have a position to start from, which is why we start from the center. And to start from the center, what you do is you turn on the machine and it'll ask you to home, so you press OK, and it goes through its process of bringing the machine back to the bottom left corner. Okay, that's the machine homed to its standard home setting. If you look at these ticks there, they're all homed. Now what we want to do is tell it to home from the center of the work area. And we know that the work area is 816 by 816. So we click on MDI, and what this allows you to do is type in your own coordinates. So type in G00, scroll this down so you can actually see it. There, and then we're going to go X 408 because 8 is half of 16, and then we're going to go to Y 408, and when I press play, it will send the machine to the exact center of the work area. And then you come back over here, scroll up, and you will home it by pressing those, or you can click the gear and check set, and this gear and check set. Don't worry about the Z-axis, because what will happen is when you come to boring out all of these holes, you'll be probing your Z-axis underneath here anyway before you start the job. So that's that. That should hopefully help you set up the machine from the center of the table. What you're going to want to do separately is when you take the board off, you're going to flip it upside down and surface it with your surfacing bit. So I'm going to delete these to show you how to do that. So when you're surfacing, click on Setup, New Setup. Everything's the same except this time when we go to stock, top offset, we're going to type 0.2. And what this does is it adds 0.2 to the top of the workpiece. Even though that 0.2 isn't there, you're going to be probing the top of that workpiece. We're still in the center, that's fine. Click OK. And that's set up. And what we've done is told the machine there's an extra 0.2 millimeters on top of the board. Now we're going to go to face, select face, and here where we select tool, we're going to select our surfacing bit, which is in my stuff. And as we see here, we've got diameter 25 surfacing bit. Click that. And it's selected that tool. Then we want to click on the face, so we click that edge. It's got the information it needs to take that edge down. Passes, multiple depths not required. And here is quite important, this transition type. See, it says smooth. If I click on that, you can see that the top option and the bottom option are allowing the tool to pass outside the workpiece. We want straight transition, the middle one, so that the tool is pretty much staying inside the workpiece. Now the reason for that is we will get a warning when we start the program because Onefinity kind of knows that the tool is bigger than the work area. Click OK, generates the tool path, and we go on simulate and press play, and as you can see, that's surfacing the board. Now, there are different patterns. Some people like to work in a sort of spiral pattern from the center of the board. I'm using this pattern. What this will do as well, if your machine needs tramming, it will leave small indented lines, and if you run your finger along it and feel which way the line is rippled, it will tell you which way your machine needs to be adjusted to get rid of those lines. So same thing again, to create a toolpath from that, you just turn on G-code, type in the name for it, save it, move it onto your USB stick, take it down to the machine, home the machine to the bottom left, order the spindle to the center. Once it's at the center, you home it again, and then you just probe to the middle of the spoil board and press run, and it will do the rest for you. If you're not satisfied with the first attempt at surfacing, all you do is run the program again, and each time that you probe, it will take 0.2 off the top, and you can just keep doing that until it's surfaced the whole board. Okay, so that's pretty much it. Hopefully that was as quick and painless as possible, but that should help you to surface and machine holes for a spoil board. So in my next video, what I'm going to do is show you how to design using Fusion a router plate, which is, this one's made of 6mm aluminium, and I'll show you how to cut that on the Onefinity CNC machine. So that'll include how I programmed all of the speeds and feeds, how I calculated those, what tools I used to do it, and how I got this nice finish. That's for the Bosch GOF 1600 router, and I'm very pleased with this. So like and subscribe and stay tuned for the next video.